Another method of solving quadratics is by using a greatest common factor. You'll notice that in these problems here, there's more than one x going on in the equation. So we can't just add the 5 and divide or take a square root. We need a few other methods to deal with this. And in some sense, we're actually doing the opposite of the distributive property. So you've seen the distributive property where we have like 3x times x minus 7. We could distribute that 3x inside and get 3x squared minus 21x. Well, when we're doing a greatest common factor, we're doing the opposite of that. So for this first one here, we're trying to find the biggest thing that goes into both of those terms. So we have a 1x squared minus a 5x. The biggest number that goes into these is just a 1. But both of them have an x. So we can take an x from each one of these and put it out in front of a set of parentheses. So just like we had with our distributive property up top there, we're taking that x out. And then what are we left with? Well, if we divide x from x squared, we're just left with an x. And if we divide x from negative 5x, we're left with a minus 5. Notice that if we distributed the x back in, we would get x squared minus 5x, right where we started. But by factoring it out like this, we need to try and find all of the x values that will make this equal to 0. Now we need to remember our zero product property, that in order for this, the x times x minus 5 to equal 0, one of these two numbers has to equal 0. So either you could let x equal 0, that's one of our answers, or this x minus 5 could equal 0. Add the 5 to the other side, we get x equals 5 as our second solution. So two different answers here, and you'll notice that 0 squared minus 5 times 0 is 0, and 5 squared is 25, minus 5 times 5 is 25, we get 0. As our answer. So x equals 0, x equals 5. In our second one here, notice that we can take out a number and a variable. For the number, we notice that both of these, the 3 and the 12, are both divisible by 3. So we can take a 3 out of both terms, and then they also both have an x squared and an x, so we could take a single x out of each one of those. Now if we take a 3x from the first one, from a 3x squared, we're still left with an x. So 3x times x gets us that 3x squared. And then what about the 12x? Well, let's put in a 4. 3x times 4 gets us that 12x. So we're dividing each of these terms by 3x. The first one we're left with an x, the second one we're left with a 4. We get 3x times x plus 4 equals 0. So what x values are going to make this equation true? Well, we want to make sure that either the 3x is equal to 0 or the x plus 4 is equal to 0. Well, if 3x equals 0, then x has to equal 0. There's one answer. And the other one, if x plus 4 equals 0, then we have an x value of negative 4. So greatest common factor, we need to be able to take any numbers or variables from everything and pull it out front in those parentheses.